Assalamualaikum and hi everyone. So in this video, I will discuss with you on how to answer all the questions that I have been setting up for your first hour tutorial. Okay, so in your first hour tutorials, we will be focusing on how to understand about the concept of rate of reaction, where rate of reaction is the changes in the concentrations over time. Okay, so the concentrations here can be for your reactants or your product, or basically it is for any chemical compounds that is involving in the chemical reaction. Okay, so the unit for your rate of reaction is depending on the unit for your concentrations and as well as time. Okay, since rate is equals to changes in the concentration, okay, over time. Okay, so let's say if I have the unit for my concentration is in molar and my time is in second, therefore the unit for my rate of reaction is molar per second. Okay, so time, okay, you can also have in the unit of minute and then hour per day or per year. Okay, so if let's say radioactive decay, so it's usually it takes years to for the reactions to take place. Therefore, if it's a rate of reaction for radioactive decay, so usually it's molar per year. Okay, so the unit of concentration varies depending on the unit states in the questions. Okay, it can be molar in capital M, or it's mole per dm cube, or it's mole per liter, and so on. Okay, if let's say my concentration is mole per liter, then the unit for my rate of reaction is mole per liter, and the time is since it is in the denominator side, so it will become time per -1. So if let's say the unit for my time is day, so per day. Alright, okay, so besides understanding the concept of rate of reaction, okay, so how to write down the formula for the rate of reaction. Okay, so in the same time you need to learn the two different types of rate of reaction: disappearance or depletion of reactants, or formations of product. Okay, so because in this one it will involve the sign negative or positive. Okay, so if it's a reactant, okay, so that means it is negative rate. Okay, but if it's a product, okay, if your compound is in the product side, that means it's a positive rate. Why is it very important for you to take note in the sign of negative or positive? Because it will relate with the differential rate law that you're going to discuss after this. Okay, so the first question here, I ask you to write down the differential rate equation for the following reaction. Okay, so differential rate equation is a formula. It's not a formula, but it's an equation, okay, which shows the relationship between the disappearance of reactants with the formation of product. Okay, so it needs the stoichiometry coefficient of both reactants and products to involve in the equation. Okay, so I have here ozone, okay, reform to form oxygen gas. Okay, so 2 in front of ozone and 3 in front of my oxygen, so its rate equals to -1/2. Where do I get these two from? It's from the in front of the ozone layer, sorry, it's in front of the ozone, which is the stoichiometry coefficient for my ozone, and it's dO3/dt, rate of concentration change versus time. So why is this negative? Because ozone is being used up. Okay, so it's a reactant. Okay, therefore negative. Okay, so equal to, okay, so this one is my oxygen and the stoichiometric coefficient for my oxygen is 3, and we are producing oxygen, so therefore positive 1/3 dO2 dt. Okay, so without this stoichiometric coefficient, you cannot relate between these two different compound. Why is it very important for you to know this relationship? Because later on, okay, we can calculate for example, the rate of reaction for the formation of oxygen based on the given value of disappearance rate of my ozone. So that's why we need to know how to write down the differential rate equation. Okay, so this is my second chemical equation given. Okay, so just to let you know, it's not strictly only applied to gaseous compounds, so it can be for aqueous compound as well. Okay, it just by accident I choose all of it in the gaseous state. Okay, so for this one we have two different reactants and two different products. So my rate equals to negative. Okay, so this one is just 1, so that means it just negative dC3H8 over dt. Because it's 1/1, which is equals to 1, so we can just ignore and don't need to write down in front of our differential rate equation. Okay, equals to negative 1/5 dO2 dt equals to positive 1/3 dCO2 dt equals to positive 1/4 dH2O over dt. Alright, so it's very easy. Okay, so you just need to remember, every time you need to write down your differential rate equation, always consider about the sign. Is either negative or is it positive? So negative for your reactants and positive is for your product. Okay, and then is your stoichiometric coefficient of your compound. Okay, so it must be 1 over the value of the stoichiometric coefficient. Okay, so then both of this negative, which is for your reactant, sometimes we refer it as rate of disappearance. Okay, or sometimes depletion. Okay, whereas the positive one, okay, is a product, so rate of formation. Or sometimes they just will just consider it as a rate of reaction. Okay, so for example, oxygen is reacting at the reaction rate of and blah 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 blah. It's something like that. Okay. Alright, so let's move on to the next chemical equation, which is your ammonia in this one. Okay, so again, rate equals to negative 1/4 dNH3 over dt equals to negative 1/5 dO2 over dt equals to positive 1/4 dNO over dt and positive 1/6 dH2O dt. So it's very compulsory for you to write down the sign, either it's negative or is it positive. Okay. Alright, let's move on to the next CLO. Okay, so just now we learned on how to write down the differential rate equation, and this time we're going to use the differential rate equation to solve problems, okay, to calculate the new rate of reaction based on the written differential rate equation. Okay, so if let's say they ask you to write down differential rate equation, so that means you need to write down a long one involving all the reactants and product that exist in the given chemical equation. But before you proceed, you need to make sure the chemical equation is balanced. Whatever it is, always remember balance the chemical equation first, and then you can proceed with the answering the questions. Okay, so when you are trying to calculate the new rate of reaction based on differential equation, okay, you just can focus on what is given to you and what you need to calculate. For example, in this question, they give you the reaction rate for pH3, okay, but they want you to calculate what is the formation rate of P4 and H2. Okay, so we just need to write down first for pH3 and P4, and then comparing pH3 with H2. Okay, they give you pH3 rate is 0.050. Okay, what does it mean by rate? It means this one is dpH3 over dt equals to 0.050 mole dm negative cube s negative 1. Okay, so you need to be alert with the given unit, because different questions will give you a different unit for rate of reaction, and your final answer must follow the given reaction rate. Okay, if it's in mole per dm cube, then your final answer must involving mole and dm cube. If it's mole per liter, and then must include liters and moles, and if it's molar, then it's molar. So you just need to be alert. And for chapter reaction kinetics, and later on you learn thermochemistry, and then after that electrochemistry. So all of these three, physical chemistry in your semester 2. Okay, so unit is very important, just like in your semester 1. Always include unit in your calculation. Okay, so I want to calculate the formation rate for my P4. Okay, so first I need to compare between my pH3 and P4 by writing down the differential rate equation that relates both of my pH3 and P4. Alright, so it's negative 1 over 4 d pH3 over dt equals to d P4 over dt. Okay, since I want to calculate this one and there is no number right in front of rate equation for my P4, that means I can just simply substitute the value of reaction rate of pH3 into the question. Okay, negative 1 over 4. Okay, so given 0.050 mole dm negative cube as negative 1 equals to dP4 over dt. Okay, so that means press your calculator now. Okay, so you should get your answer equals to 0.0125 mole dm negative cube as negative 1. So this is the rate of reaction for P4. Okay, so what about for hydrogen? Okay, what about for hydrogen? Okay, so get a line here. Okay, so negative 1 over 4 dpH3 over dt equals to positive 1 over 6 dH2 over dt. Okay, I forgot to remind you, okay, or to mention to you. Okay, so the negative and positive sign is compulsory when you are writing down differential rate equation. But when you are trying to solve the questions, and you can just ignore the sign. Okay, for example, in this one, negative 1 over 4 dpH3 over dt equals to positive 1 over 6 dH2 dt. And then I'm going to rearrange the number so that on my right side I only have dH2 over dt, which is the formation rate for my hydrogen. So what I'm going to do, I'm going to move the 6 to the left side, so it becomes 6 over 4 dpH3 over dt, and I'm going to completely ignore the sign here, negative or positive. You can just ignore. Alright, and then I'm going to substitute with the formula, and then I'm going to substitute with the value of the reaction rate of my pH3, which is given in the question, 0.050. Always include unit. Okay, equals to formation rate for my hydrogen gas. And if you press your calculator, you will get your answer to be 0.075. Okay, make sure to write down the unit, the final unit in the final answer. That's it. Okay, that's easy, very simple. Okay, you just need to make sure you write down the correct differential rate equation. Okay, so again, it will be back to the balanced chemical equation. Okay, so this one, okay, they use a specific term, which is depletion rate of ammonia and formation rate of water. So we're going to do depletion rate of ammonia first. Okay, from the questions, they give you disappearance rate of oxygen. So disappearance, depletion is actually the same words, same meaning. Means how fast is ammonia and oxygen is being used up in the chemical reaction. Okay, so disappearance rate of oxygen is referring to dO2 over dt, which is equal to 0.020 molar per second. Okay, so let's solve for depletion rate of ammonia first. Okay, so negative 1 over 5 dO2 over dt equals to negative 1 over 4 dNH3 over dt. Okay, and I have to rearrange the number first, and like I said before, we can just simply ignore the sign here, so it becomes 4 over 5 dO2 over dt equals to dNH3 over dt, which is the rate of reaction for my ammonia. Okay, then we're going to substitute the value of disappearance rate of oxygen into the new formula. So 4 over 5 times with 0.020, which is equals to 0.016, which is equals to the disappearance rate of my ammonia. Okay, and what about if the formation rate of my water? Okay, so let's relate between the oxygen and water. Okay, since just now we already calculate the disappearance rate of ammonia. Okay, to solve the question formation rate of water, so you have two different values of rate of reaction now. Okay, so one is in the rate of reaction for my oxygen, okay, given in the question, and secondly you have the rate of reaction of ammonia, which you calculate before. Okay, so you can use these two, either one of these, okay, to solve for the formation rate of water. But I'm going just to stick with what is given in case I've wrongly calculate my disappearance rate of ammonia. Okay, so negative 1 over 5 dO2 over dt equals to positive 1 over 6 dH2O over dt. Okay, then I'm going to rearrange the numbers. I'm going to ignore the sign. So 6 over 5 dO2 over dt equals to dH2O over dt. So 6 over 5 times with 0.020 molar per second. Okay, then you press your calculator and you will get the answer to be 0.024 molar per second. Make sure to write down the unit. Okay, that's all for our first hour tutorial this week. Okay, make sure to try to answer your second hour tutorial. Thank you for watching.